So hi everyone, I'm Jay and today we are going to see the timing diagram of the memory write machine cycle. So you can see that on the screen there is a one microprocessor which is connected to the memory. To connect the microprocessor with the memory, we need some signals such as some control signals which is memory read and memory write, and we need some bus such as data bus and the address bus. You can see that on the screen, this is the timing diagram of the memory write cycle. What is timing diagram? Using the timing diagram, we can see different signals using which we can understand that what are the steps which is done by the microprocessor to perform one machine cycle. Let's see all the signals in the timing diagram. So there is a clock, then there is a higher order address bus which is A8 to A15, there is a dedicated address bus. Then there is a ALE which is address latch enable. Then AD0 to AD7, it is a multiplexed bus. And to use the AD0 to AD7 as A0 to A7, we will use the address latch enable. You know that, right? The lower order bus is multiplexed. The AD0 to AD7 is multiplexed, and that can be either used as A0 to A7, which is a lower order address bus, or D0 to D7. And to bifurcate the AD0 to AD7 to address bus or data bus, we will use the signal that is ALE. Then there is a IO/M bar and the read bar, which are control signals. Now let's see the first signal, which is clock. The T state is known as from where the clock is started and at the same point clock ends. So when clock completes one cycle, it will be considered as one T state. Then there is a higher order bus which is A to A15. Now to write the data from the microprocessor to memory, processor has to send the address to where it wants to store the data, and processor will use the address bus to send the address to the memory. Right now the microprocessor wants to write some data in the memory location 2000H. So processor will put 2000H in the address bus. But now there is a problem. What is the problem? That processor can put the higher order value of the address in A8 to A15 because A8 to A15 is a dedicated address bus. But processor cannot put the lower address value 00 in the AD0 to AD7 because the processor has to first convert the AD0 to AD7 into A0 to A7. So you can see that the processor will put the higher order address in A to A15, that is 20. To put the 00 in the AD0 to AD7, the AD0 to AD7 should be first converted into A0 to A7, and for that the processor will use the ALE. When ALE is given, the AD0 to AD7 will be considered as A0 to A7 and processor will put the lower address in A0 to A7, that is 00. So you can see that the processor has successfully put the address value 2000 in the address bus and memory has received the 2000H address. Now when the memory receives the address, it understands that processor wants to select that particular address. So memory will select that address. You can see that the address 2000H is selected. Now particular address is selected. Now processor has to write some data to that selected address. Now let's see how it's done. You can see that the next two state for the memory write machine cycle timing diagram is T2 and T3. To write the data, processor has to generate the control signal which is memory write. If you remember, in the generation of control signal, microprocessor does not have the memory write signal. Processor has to generate the memory write signal by combining different signals such as IO/M bar and write bar. So to generate the memory write, the processor will combine two signals which is IO/M bar. The value of the IO/M bar will be 0 and the value of the write bar will also be low. And when microprocessor will combine these two signals, the memory write signal will be generated. So So you can see that on the screen the processor has sent the memory write signal to the memory. So when memory receives the memory write control signal, memory understands that processor wants to write some data on the selected memory location. Which is selected memory location? 2000H. So when memory receives the memory write control signal, it will wait for the data which will be sent by the microprocessor. So after some time, the processor will send some data using the data bus to the selected location, and data will be stored in the memory location 2000H. So you can clearly understand that using the timing diagram, we can see all the waveforms, and by seeing the waveform, we can clearly understand that what are the steps which is done by the microprocessor to perform the memory write machine cycle. And I hope this concept is clear to you, and this is it for this session. If you still have any doubt, you can ask me in the comment section, and thank you so much.